So question 155, actually it's 5 questions, all headed under question 155. But like I say, integration is such a big topic, and it's the only way we can cover it. So for this integral, I'm going to use the method of integration by substitution. And cos to the 4x, what does that mean? Okay, sorry, cos to the 2x. Well, that's the same as cos 2x to the power 4. So the substitution I'm going to use is u equals cos 2x. So if I differentiate u to get du dx, I get minus 2 sine 2x. And that's quite interesting because I've got sine 2x dx here. So if I can rearrange this to say sine 2x dx equals something, then I can substitute that for the sine 2x dx in one go. So multiplying up the dx and dividing by minus 2, I get an expression for sine 2x dx. So I can replace sine 2x dx with a half du, and then the cos to the 2x is basically u to the power 4. So therefore this integral we're trying to do simplifies down to the integral of minus a half u to the 4 du. I've substituted the sine 2x dx with a minus a half du as the minus a half du, and cos to the 2x is u to the power 4. That's in the middle there. So then we can do this integration by increasing the power and dividing by the new power, and that gives us that, replacing the u with cos 2x. So that's the answer to this first part of the question. Now we want to integrate 2x plus 3 tan squared 5x. Well, the 2x part is not too difficult, shouldn't be. And but we need to integrate tan squared. Well, we can integrate tan. The integral of tan is sec squared. But what about the integral of tan squared? Well, when I see something like this, I think of the trig identity, which includes tan squared and sec squared. So sec squared is 1 plus tan squared. So that means that tan squared 5x is sec squared 5x minus 1. So I can replace this tan squared 5x with sec squared 5x minus 1. So I have to multiply it by 3. So the integral we're trying to perform breaks down into these 3 components now. And now I can integrate sec squared to tan. And that's the answer to that. We're dividing by 5 because of the 5x here. Okay, so that's the answer to the second part of this question. So this part of the question is asking us to find a general solution to this differential equation. So the first thing I'm going to have to do is to separate the variables. I'm going to have to divide by tan y to get the tan y over to the other side. I'll get 1 over tan y, which is the same as cot y. The dy will stay where it is. I'm going to divide by 2 plus 3x cubed and multiply by dx. So when I do that cross multiplication, I get this equation now. So now I've separated the variables. I've got all of the y's on one side and all of the x's on the other. I'm now ready to integrate each side. So How do I integrate cot y dy? Well, this is an integral which is in the formula book for A level. That's ln sine y. But what about this? Well, this also looks a bit like a ln integral because the differential of 3x cubed, differential of the denominator, 2 plus 3x cubed, is a multiple of x squared. So if I, just to explain this, express f of x to be 2 plus 3x cubed, then dashed x would be 9x squared. So x squared is 1/9 f of x. So that means that this integral that we are trying to perform can be expressed in this form. So the x squared I've replaced with 1/9 f dashed x, and the f of x is the 2 plus 3x cubed. So you should now be able to recognize that when we're integrating f dashed x over f of x, that's just ln of f of x. But I've got this 1/9 here, so it's 1/9 ln f of x. So when I put that into my integration, then I get ln sine y, as I said, is 1/9 ln f of x. Well, f of x was what I called 2 plus 3x cubed. So you could say that that is an answer to the question, the general solution to the differential equation. Sometimes questions ask you to express the answer in a particular form. I haven't stated a particular form here, but what I can do is I can combine bring the 1/9 into the power of the ln. Also convert the c into ln k, where k is a constant, and then combine the two lns on the right hand side, and then finally take the lns away to give me the final answer here. So the ln k, the 1/9 came into the power of the 2 plus 3x cubed here, and then ln k, because it's a plus here, becomes multiply inside the ln. And then when I take the lns away, I get sine y equals k times 2 plus 3x cubed to the power 1/9. So in this question, we have another differential equation, but this one is being used to model the amount of water in a tank. We've got water flowing in and water flowing out. The first part of the question is to state the rate at which water is flowing in. Well, if you look at this differential equation, this is saying that the rate of change, or 300 times the rate of change of volume, is 450. That's the plus, that's the positive amount of volume going into the tank. And then we've got this element, the minus 2v, tells us how much is leaking out of the tank. So the amount going into the tank is 450. What are the units? Well, we've got cubic centimeters here, seconds here. So the amount of water flowing into the tank is 450 cubic centimeters per second. So now we have to find a solution to the equation in a particular form, and we're told that the tank is initially empty. So here's the equation, and as in the case of most differential equations, we need to separate the variables. So I'm going to bring the t over to the other side by multiplying by both sides by dt. And then I've got this bracket here, this factor, which has got the v in it. That needs to go over to the other side. So I divide by that factor to give me the equation now where the variables are separated. Now I can integrate both sides. So the right-hand integral is probably straightforward enough for most people, so it's straightforward enough for me. Here though, on the left-hand side, we can think of this as 300 times the integral of 1 over 450 minus 2v dv. So this would be a Lin integral. It's not just, though, the integral of 450 minus 2v. We then need to divide by the minus 2. So there's 300, which I took out of the integral. Ln 450 minus 2v, and then dividing by minus 2. And then the integral of 1 is t plus our constant of integration. We're told that initially the tank is empty, so when t is 0, v is 0. Putting t is 0 and v is 0 into this, we get c is minus 150 ln 450. So we can put that into there. And we get this equation, which I need to now find. I mean, this is a solution to the equation, but we've got to write the solution in a particular form. So somehow we've got to extract the v from all of this. The first thing I'm going to do is to divide everything by minus 150. So that's slightly tidier. What can I do now? Well, I've got these two lins. So if I bring the lin both over to the same side, then I can combine these two lins. Let's just run out of space here. So let's just take this and put that on the next page. So I can combine these two lins. Ln of A minus ln B is ln A divided by B. So that combines it into a single ln, and then I raise e to the power of each side, and I get this now. So I'm getting a little bit closer to my objective, which is to make v the subject of this. So I can multiply by 450 and then rearrange to make 2v, and then finally divide by 2. So at last we get the answer, the solution to the differential equation in the required form. Thank goodness for that. Okay, what's the next part of the question? The next part says find the volume of water in the tank after 3 minutes. 3 minutes here, but t is in seconds. So that means we need to put a value of t equals 180. So when t is 180, we put 180 there and we get the volume, and that's 157 cubic centimeters. Have we completed the question? No, we haven't. We've still got to write down the limiting value of v as t tends to infinity. Well, as t gets larger and larger and larger, e to the minus 1 over 150t gets closer and closer to 0, and therefore this term gets closer and closer to 0, and the limiting value is then 225 cubic centimeters. Okay, so that's that one. One more part to go. So this integral is the integral of a function times a function, x squared times e to the 2x cubed. And I could perform this by using integration by parts, possibly. But I'm looking at the fact that we've got 2x cubed here in the exponent of e, and the differential of 2x cubed is a multiple of x squared we've got here. So that leads me to think that a substitution might be the best way to go here. So for my substitution, I'm going to make u equal to the exponent, the 2x cubed. Then differentiating that, du dx is 6x squared. So I can rearrange this to give me an expression for x squared dx. And that's useful because I've got x squared dx here. So I can replace the x squared dx with 1/6 du. And the e to the 2x cubed becomes e to the u. So my integral, once I've done this substitution, comes down to something which is much more straightforward. The integral of 1/6 e to the u with respect to u is 1/6 e to the u plus c, of course, not forgetting the constant of integration. And then finally, I substitute 2x cubed back for u to get the final answer. So there we are, another example of integration by substitution, very powerful method of integration.